matrices, lesson 2.4, and be sure and include today's date. Alright, here we go. Like usual, when we're studying something new, let's start off with a definition, okay? So let's look at the definition of a matrix. Please copy this in your notes. A matrix is a rectangular array or an order of numbers in rows and columns enclosed in brackets, okay? Now I'm going to explain that a little better in just a second. In fact, I'm going to give you an example of this in a second, but for right now, just copy this down, please, in your notes. A matrix is a rectangular array of numbers in rows and columns enclosed in brackets, okay? Now, here's an example. This would be a matrix. You can copy these examples down, or you can just watch. It's up to you. There we go. My numbers are 1, 2, 3, 7, -5, and 1/2. Notice I have perfect rows going up and down this way. I'm sorry. Those are not called rows. I'm sorry. You have perfect columns going up and down, all lined up, and you have perfect rows lined up going across. That is a matrix. That is a matrix. They come in any shape you want. It can be really long, which is one row of numbers, 8, 5, 6, -3/4, -20, okay? It could be really long like this way. It could have a lot of numbers. I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So a matrix is any rectangular array of numbers in rows and columns enclosed in brackets. Okay, that's it. So all of these are matrices, okay? They're just brackets with numbers on the inside. Now, do understand they're in order. You don't have a 1 here, and a 7 over here, and a 3 here, and a 2 over here, and a -1 right here, and a 6 over here, and an 11 here. They're lined up in columns and rows, okay? Alright, so those are examples of matrices. Now, before we get to adding and subtracting matrices, we have a lot of information to cover, and you are responsible for this information on tests and quizzes, so please take really good notes. Every matrix has an order or dimension, okay? It has an order. Should be an N right there. Every matrix has an order or dimension. Now let me show you what I mean. You do want to take notes on this. Copy this down. Let's write a matrix. I'm just going to put 1, 8, 7, 2, 9, 1. Okay? Now if I could ask you for either the order or the dimensions of this matrix, when it comes to matrices, the words order or dimension mean the same thing, okay? And here's what it's talking about. You count the rows first. How many rows do I have? 1, 2. Write that down, please. Now count the columns. 1, 2, 3. 3 columns. And you put a little X here. Now that X does not mean multiply. It means by. Okay, so we call this a 2 by 3 matrix. A 2 by 3 because it has 2 rows and 3 columns. Got it? It's that simple. It's a piece of cake. 2 rows, 3 columns. So we call that a 2 by 3. By the way, your rows always come first in your order or dimension, and your columns come second. Okay? So this is a 2 by 3. Now, just to help you not forget which ones are called columns, think in the olden days when you used to have a, here's the yard out front, and the house that's back here. I'm not very good at drawing, obviously, but here's a house, and there's the roof, and in the front sometimes would have pillars, columns going up and down. That looks horrible, doesn't it? It looks like a spaceship. But you get the point, don't you? Sometimes on the front of old porches and old patios, there were columns going up and down. Columns do not run this way. Columns run this way, up and down, okay? So that should help you remember. Columns go up and down, rows go this way, okay? this matrix? What is the dimension of that matrix? Okay? Or what is the order? What is the order, or what is the dimension of that matrix? Well, what comes first? The rows. Okay, rows comes first. Gotta remember that. Rows, then columns, okay? So how many rows do I have? 1, 2, 3. I have 3 rows. How many columns do I have? 1. So this is a 3 by 1 matrix. A 3 by 1. It's not a 1 by 3. A 1 by 3 would look like this. This is a 1 by 3. 1 row, 3 columns, okay? This is a 3 by 1 matrix, okay? One more and I'm finished. Okay, if I asked you what is the order or dimension of this matrix, you would count the rows first. 3 rows. Count the columns. 1, 2, 3, 4. So this is called a 3 by 4 matrix. A 3 by 4 matrix. Okay, so I hope you guys understand how to find the dimension or order of a matrix. Alright, let's continue on. If I get my pen to work here, there we go. The numbers in a matrix are called entries or elements. You need to know that. Make note of that in your notes. Write this down. The numbers in a matrix are called entries or elements. So, if I had a matrix like this, I would say my entries are 1, 2, 3, 4, or my elements are 1, 2, 3, and 4. Okay? So the numbers inside of a matrix are called entries or elements. There are different kinds of matrices. I'm going to go over them now, and I'm going to go kind of fast, so you have to pause the video if you need to, okay? You are not responsible for these definitions. Let me say that again. You are not responsible for these definitions. In other words, I'm not going to ask you to quote these. But you do need to understand what I'm talking about when I use these terms, okay? So when I say row matrix, write this down please, put the words row matrix in your notes. Here's what I'm talking about. It is a matrix that has a row, 1 row. It could look like that, 1, 5, 7. It could be really short. It could have 1 number in it. It could have a ton of numbers in it. It could be like this. Okay, 1, 8, 7, 3, -8, 15, 27. A row matrix is any matrix that has 1 row. Got it? Moving on. That is a row matrix. Well, you know what a column matrix is? A column matrix is a matrix that has 1 column. So it could look like this. This would be a column matrix. 8, 10, -3. It could have just 1 number. You say, well, Mr. Error, that's a row matrix. Yeah, it's a row matrix. It's also a column matrix, both. It could be either one, okay? Here's a row, here's a column matrix. It could be really long. It could be really long with a bunch of numbers. 1, 2, 3, 4, 5, 6, whatever. You get the idea, okay? So a row matrix is a matrix that has 1 row. A column matrix is a matrix that has 1 column, okay? Alright, let's continue on. A square matrix is any matrix in which the rows and the columns are the same. For example, please take some good notes on this. This is a square matrix. How many rows do I have? 1. How many columns do I have? 1. This is a 1 by 1. That's a square matrix because this number here matches this number here. This would be a square matrix because I have 2 rows and 2 columns. This is a 2 by 2. This would be a square matrix. There we go, because I have 3 rows and 3 columns. So this would be a 3 by 3. the idea? I could write for you a 4 by 4 or a 5 by 5 or a 6 by 6 if I wanted to, so on and so forth. But a square matrix is any matrix in which the row is the same as the column. 1 by 1, 2 by 2, 3 by 3. Got it? That's a square matrix. A zero matrix is any matrix of any size. I don't care what it looks like, as long as all of the entries or elements, whatever you want to call them, all of the entries or elements are 0. So it could be a really small matrix like this, or it could be a very large matrix like this, as long as every single entry is a 0. There cannot be one exception. As long as all the entries are 0, then you have a zero matrix. Doesn't matter if it's a square matrix, a row matrix, a column matrix, none of that matters. The only thing that matters for a zero matrix is that every entry or every element is a 0. Okay? So I'm not going to ask you to quote those definitions, but during class, when I say the words row matrix or column matrix or square matrix or zero matrix, you should understand what I'm talking about. Okay? Now, let's take a look at adding and subtracting matrices. Okay? Here's the first things you need to know. Please copy both of these down. Are you ready? Copy both of these down. Matrices must have the same order or dimension, whichever word you want to use, it doesn't matter. Matrices must have the same order / dimension in order to be added or subtracted. Got it? In other words, if you have a 2 by 2 matrix here, you cannot add to that a 4 by 2 matrix. You have to have a 4 by 2 and a 4 by 2, or a 2 by 2 and a 2 by 2. Matrices must have the same order or dimension, whatever word you want to use, in order to be added or subtracted. Got it? Must be that way, or you cannot add them. Second thing I want you to write down: if two matrices do not have the same order or dimension, then they cannot be added or subtracted. Obviously, I just said that. Your answer would be no solution. So on a test or a quiz, if I ever try to test you and I give you a 2 by 3, and I tell you to subtract from that this here, and this of course is a 3 by 2, 3 rows, 2 columns. This is 2 rows, 3 columns. This is a 2 by 3, and this is a 3 by 2. The answer is no solution. You cannot add or subtract matrices unless they have the exact same order or dimension. So if this is a 2 by 3, this has to be a 2 by 3, or if this is a 3 by 2, this has to be a 3 by 2 over here. Okay? But they have to have the same dimension. So, this is a pretty fast video. We're going to do 1, 2, 3, 4 examples and we're finished, okay? So please copy this first example down and we'll get started. Please copy this down and we'll get started. Now notice I'm adding 2 matrices, okay? So the first thing you would do is run a test and make sure that you can add these. This is a 2 by 3. I'm sorry, that's incorrect. This is a 3 by 2. And this matrix over here is also a 3 by 2. So that's good, isn't it? That means we can add them. It is so easy what we do now. So easy. And by the way, if you struggle with signed numbers, positive and negative numbers, use a calculator. Okay? This element corresponds with this element. So 5 plus negative 2 is 3. This element corresponds with this element. So negative 3 plus 1 is negative 2. This entry corresponds with this entry. Negative 3 plus 3 is 0. This entry corresponds with this entry, so 4 plus 0 is 4. 0 corresponds with this entry. 0 plus 4 is 4. And then this entry here corresponds with this entry here. 7 plus negative 3 is 4. There we go. That's simple. That's all you have to do when you're adding matrices. It is just not difficult. Okay? Alright, let's try another one. Now let's subtract two matrices. Now, I want to give you some advice here. I would like you to stop and not take notes for me. Go ahead and copy this down. You can do that, but when you're done copying this down, stop and just listen for a second. Most students would agree that adding addition is easier than subtracting. Most students would agree with that. Most would. I would like to recommend that subtracting these two matrices might not be a good idea. Let me show you why. Again, don't take notes, just watch. I have 8 minus 2. 8 minus 2. No, that's easy. That's 6, no problem. But now I have 3 minus a negative 7. Well, that's going to be 10. Because 3 minus a negative 7. Remember, we've learned this. Whenever a number has two signs, if the signs are the same, it becomes positive. So now I get a 10. 3 minus a negative 7 is 10. That's confusing. I'm going to show you a better way to do this in a second, okay? Just sit back and watch. Negative 4 minus a negative 6. Negative 4 minus a negative 6. Well, the signs are the same. That makes that a positive. Bring down your negative 4. You owe me $4. You pay out, you have 6, you pay off your debt, you're left with 2. And then lastly, I have 0 right here, minus 1, that's negative 1. 0 minus 1, negative 1. Now, what I'm trying to say to you, and I hope you're listening to me, I asked you not to take notes on this. I'm trying to show you that when you're dealing with subtraction, the signs can really be easy to mess up on, okay? They really can be. So I would like to recommend whenever you're subtracting matrices, I would recommend that you change the minus sign to a plus sign. See this? I would change it to a plus sign. Well, Mr. Earhart, are you allowed to do that? Yes, you're allowed to do that as long as you go through here and change all the signs. So you're allowed to make this become positive. You're allowed to do that as long as you change all the signs over here. So your positive 2 becomes a negative 2. Your negative 7 becomes a positive 7. Negative 6 becomes 6. And 1 becomes negative 1. And now you can add and we'll get the exact same answer. 8 plus a negative 2 is 6. 3 plus 7 is 10. Negative 4 plus 6 is 2. And 0 plus a negative 1 is negative 1. You get the exact same answer. Now, some students don't like that suggestion. That's totally fine. Others do. For me, I would much rather change this to a plus sign and go through and change all the signs over here. And then just add. That's a lot easier than trying to go through and subtract and watch all my signs, but that's up to you. Whatever you recommend, whatever you are comfortable with is fine with me, okay? Alright, let's try another problem. Okay, now this is interesting here. We're really not adding or subtracting, but we're going to take a number that's outside the matrix. And of course, you can probably figure this out. This number right outside the matrix means multiplication. So we're going to take this number and multiply it through. So 4 times negative 2 is negative 8. 4 times 4 is 16. 4 times 0 is 0. 4 times negative 1 is negative 4. Wow, talk about easy. Piece of cake. Okay, so we're simply taking a scalar. They call that number on the outside. Sometimes they call it a scalar. S-C-A-L-A-R. And they multiply that scalar through the matrix. So whenever there's a number outside the matrix like this right next to it, it simply means to multiply it through. Pretty simple. And last problem. Now this one will be a lot more complex. Notice I've got brackets here, parentheses here. So I'm going to start inside the parentheses and add these two matrices first. So I'm going to bring down my negative 2, put my parentheses, and then I'm going to add these two matrices. Okay? So I brought down my negative 2, brought down my parentheses. Now here we go. 1 plus negative 4, negative 3, negative 2 plus 5, 3, 0 plus 6, 6, 3 plus negative 8, negative 5. There we go. Now bring down this over here, so I have minus a negative 9, a positive 15, a positive 8, and a negative 8. Now, looking at this, what do you think you do next? Think of order of operations. You don't subtract these two matrices first. We have multiplication first. Look, if you had this, if you had negative 2 times a number and then minus a number like this, you would do your multiplication first. Okay? So same thing with matrices. We're going to do our multiplication first. Alright? So let's take our negative 2 and multiply it through here. Negative 2 times negative 3, positive 6. Negative 2 times positive 3, negative 6. Negative 2 times 6, negative 12. Negative 2 times negative 5, positive 10. Then bring this down right here. Now please feel free to subtract these two matrices. Please feel free to do that. I don't do it that way, but you're welcome to. Whenever I'm subtracting two matrices, I change this to a plus, and I go through and change all these signs. That becomes positive, negative, negative, positive, and now I'm ready to finish the problem. 6 plus 9, 15. Negative 6 plus negative 15, negative 21. Negative 12 plus negative 8, negative 20. 10 plus 8, 18. And we're finished. Okay, students, so there we go. And that's it for today. Adding and subtracting matrices is really a pretty simple mathematical concept to learn. It's not that difficult. Just remember, you can never add or subtract matrices unless they have the same order or dimension. And if they do, it's very simple. You just simply add or subtract corresponding element with corresponding element. And it's that simple. If you have any questions, don't hesitate to call or email.